Part 2 of our force, mass, and acceleration lab. We added masses to the hanger, which increased the net force and measured the corresponding acceleration. Once you put your mass of the hangers and your accelerations 1, 2, and 3 in the spreadsheet, there's some ways we can get the computer to calculate some things for us. To do that, we can take the masses and calculate them from grams to kilograms. How many grams are in a kilogram? 1,000, you say? To do that, go ahead and click equals in the cell that you want to do that. And then we want to take that original 25 grams, which selects cell A2, and you're going to divide that by 1,000 because there's 1,000 grams in a kilogram. When you hit equals, you might have a little green box pop up here, and if so, you can click check the box if you'd like to apply that to the rest of the column. If not, you can grab this, select that cell again, and you can grab this blue dot and just drag it down to here. Next up, we have to calculate the net force. Well, the net force in this case happens to be the weight of the hanger. So to calculate the weight of the hanger, you need the gravitational field strength constant times the mass of the hanger in kilograms. So again, we're going to hit equals to do a calculation. We're going to take the mass of the hanger, and you're going to multiply it by hitting Shift 8, which is the asterisk, and we're going to multiply that by 9.81 newtons per kilogram. Don't put the units in the calculation, and we'll go ahead and set that in there. Again, to apply that to the rest of the column, a box might show up here and hit the green button. Otherwise, grab the blue dot, drag it down, and it will apply that formula to the rest of the column. Next up, we want to find the average acceleration of our 3 trials. So over here, in average acceleration, there's about 3 different ways you could do this. You could put a formula that would add those all up, take the sum and divide it by 3, or you could type in average and select. I found the easiest way to do this is to click up here, click the cell, and this happens to be G2 right now, and go up to here where it says sum. Well, it has a lot of calculations in here, and under average, you can click average, and then they want us to select cells to fix the average of. So I'm going to highlight those 3 accelerations again and hit enter. Oh, here's that green box that I talked to you might show up. So I'm going to go ahead and say yes, apply this to the rest of the column, and there you go. Because these values here have so many decimal points, I'm going to go ahead and highlight that, and then we're going to take this down to the number of digits that our data had from lab yesterday. Next up, we want to insert a graph. To do that, we need to select the 2 columns. To do that, you would select column G. On a Chromebook, I believe you have to hit Control before selecting the other column. On a MacBook, you use Command to select, and then click the other column. So we've selected these 2 columns that we want to have for our graph because we're trying to make an acceleration versus net force graph. And we're going to insert, you'd think it would say graph, but we're going to insert a chart. When that popped up there, it gives us an acceleration versus net force graph. Average acceleration is on the y-axis and net force is on the x-axis. That makes me wonder if I didn't put my units at the top of my average acceleration. I did not. I'm going to go ahead and put this up here. Meters per second. Close that. I'm going to delete. We're going to try that one again. Select, insert a chart, and then the units show up in there. I'm going to go ahead and shrink this so that we can see both of these at one time. So to get that chart editor to pop up, you can either double click on the graph or you can go over here and open up chart editor. It's a really good idea in setup. Make sure that you have a scatter plot as opposed to one of these other kinds of graphs. If not, you can scroll through here and select scatter, but this one now has the correct one. Also in here, you want to double check are the titles and, more importantly, the values for the net force and acceleration correct. Acceleration was a little over 1. I'm sorry, the net force was just a little over 1. I'm looking at the biggest acceleration. It's a little over 2. And if I look on the y-axis, the acceleration's here, and the biggest value is a little over 2. And the titles match up, and there are units. Next up, we want to find the slope. To do that, you can go into Customize, click Series. You want to find something for a best fit line, looking at these possibilities down here. Click Trend Line and go down about 3 of these next lines. And under Label, you're going to open this toggle switch up and choose Use Equation, where then it'll give you the slope. The slope of my graph up here will not match yours because this is made up data here. If you don't have a title or have not labeled your axes, to do that, you can also go over in the Customize column and go under Chart Title and Axes. You can click Chart Title and then type in the title you want in this section here. In that same spot, you can go to the horizontal axis and type in this space here the name of the variable and the units for the x-axis. In this case, it's net force measured in newtons, and then go to the same place and type in the vertical axis. At that point, you should have an appropriate title for the graph, labels with units for the y-axis, labels with units for the x-axis. And up here, you've got your y equals mx plus b. The y, they give you the name of the y-axis, equals. Here we have the value of the slope. Unfortunately, it does not include the units, so you'll have to write down that the units were in meters per second squared per Newton. Times x, what's the name of our x-axis? That'd be net force, and then plus the y-intercept. Please remember the y-intercept is a y value, so the units for that would be meters per second squared. And again, if you've got a y-intercept that ends in e negative something, that means it's very, very close to 0, and you can claim that y-intercept is 0. I hope that helps.